Ian, are you ready?
Submitting it now.
Okay. All right, so let's go through the textbook check, and then we'll talk a little bit about functions. And then I'm going to go through the quiz. So Maddie, you'll just go next door and finish it while I go through it with everyone else. Because everyone else in here has taken it, correct?
Yes.
Okay. Okay, so does the diagram below represent a relation, function, neither, or both? Tell me what a relation is. Is anybody prepared for 2-5?
That'd be like something that's similar to the original, right?
Or that they would be like together, kind of. They have like the same number, like 2 and 4, kind of a relationship of 2.
Okay. A relation is very broad. So if I wanted to say I've got these relations, I could use any number. It doesn't matter what it's mapped to. These are all relationships that I'm just creating as I go. Okay? Any of these left to right can be mapped to any number. Relation is any relationship between x and y. Okay? A function is a special kind of relation. Who can explain to me what a function is?
The number that is created from a relation.
No. There's something special that makes it a function. A function, you can never map more than one y to an x value. You can never map more than one y. So for every input into a function, there's exactly one output. There's not more than one output. So if I look here, if I mapped 2 to 1 and 2 to 2, this is not a function because there's two outputs for the same input. Okay, so for every input, there's exactly one output. That's a function.
It's a one-to-one.
Mm-hmm. Okay. And it's not technically one-to-one. A one-to-one function means for every input, there's exactly one output, and for every output, there's exactly one input. That's a one-to-one function, which we'll learn later. But a function means this, I cannot map an input to more than one output. The video does a good job of explaining the function machine and kind of how a function, when numbers go in, they can just have one output to kind of give you a visual. But functions are written with this notation, f of x. So if you see f of x, that tells you that what's coming is in fact a function. Okay? But don't get confused when you see this. This does not mean f times x. This just means f of x. You can replace f of x with the letter y, and it means the same thing. Okay, so if I have f of x equals x squared plus 2, if it helps you and you're not confused by that, you can just replace it with y equals x squared plus 2. F of x and y you can interchange. Okay, this just tells you what's coming is in fact a function. That for every input here, there's exactly one output. Okay, so if I look at the first question, does the diagram below represent a relation, a function, neither, or both?
A function and a relation.
Does every input have exactly one output?
Yeah.
Yep. 5 goes to 1, negative 1 goes to 2, 6 goes to 3, 7 goes to 2. 7 doesn't go to more than one y value, or more than one output, right? So this is a relation and a function. All of these would be relations. Even if it's not a function, there's a relationship between x and y. But a function is more specific. And it does meet the definition of a function as well. The input value, or x, is considered the dependent variable. False. I always think of it as, if I have an equation, I can pick whatever I want for x, and y depends on what I pick on x for x. So y is dependent, x is independent. Okay, because y depends on what I pick for x. Question 3. What test can be performed on a graph to determine whether it is a function?
I put vertical line graph. Vertical line test. That's what I put.
You put vertical line test?
Yeah, I just see what's wrong.
It is vertical line test. Vertical. So I'll have to check that and see. What you do to determine if it's a function is a vertical line test, because that test is seeing whether this graph goes through this point at more than one place, because that would tell you that there's more than one output. As an example, this graph is not, it's a relation, but it's not a function, because when I put a vertical line through it, it goes through at more than one place. So vertical line test is correct. Okay, I'll go check that for you. How would the following graph be represented in interval notation? So the other piece that's presented in this section is something called piecewise functions. And piecewise functions are just not continuous functions. There's a piece that is represented by one graph, one equation, and then you've got another equation that's represented from this point forward. So they're piecewise functions. And so we're learning how to talk about domain and range in this section. Who knows what domain is? If I asked you a domain of a function, what am I asking? All the values of x that exist. Yep. And the range? All the values of y. So if I'm looking for the domain of this function, this line goes on forever to the left. And remember, when we're writing the values, we're going from left to right. So it's negative infinity to negative 2, and including negative 2, so there'll be a bracket, union with negative 1 with an open parenthesis to positive infinity. We always go left to right. So it'd be negative infinity to negative 2 bracket, and then parenthesis negative 1 to infinity. So it's this last one. So we're back to interval notation in this section too. What's the domain of this function? All the x values this function includes. Yep. Because you can see it goes forever to the right and goes forever to the left. So it's going to include all real numbers, negative infinity to infinity. Okay.
That's what I put, and then it changed my answer because it took so long to load.